Hello everyone, and I'm Ravikumar Jedy. I'm here with the next topic, that is, in the last class, if you remember, we have discussed about the convex mirror was the last topic. It was with hither and thither. So today, once again, I'll explain you both the concepts, that is, of image formation in the convex mirror. This is the physics part, the light chapter which we were dealing with. So here, the image formation in the convex mirror. As you all know, the convex mirror definition, that convex mirror is the part of a spherical mirror in which the reflecting portion, in which the reflecting surface is curved outwards. You can say the convex mirror is the part of a spherical mirror in which the reflecting surface, this is the reflecting surface, this is the reflecting surface. So this reflecting surface is curved outwards, we call it as convex mirror, and this portion, this is M dash is the aperture, M is the aperture, that is portion of the reflecting surface of a spherical mirror, we call it as aperture, and center of this aperture we will call it as P, that is pole. Okay, so now if I draw a straight line, which is passing through this pole, we call it as principal axis. Okay, we call it as principal axis, and this straight line will be passing through the center of curvature also, that is center of curvature. Okay, and let us consider this as principal focus. If you observe here, you could see that the center of curvature and the principal focus, are lying onto the left hand side, that is behind the mirror. They are behind the mirror. Is that clear? Okay. So now, if you place on the left hand side, it is in front of the reflecting surface. Okay. So anywhere in front of the reflecting surface, if you place the object, where is that you are going to get the image? Let us see now. So as we have discussed in the previous class, that is in two cases, there are only two cases here in the convex mirror, that is one is at infinity and second one is anywhere in front of the convex mirror, which means that no matter wherever you place the object in front of the convex mirror, you will be getting the image at one position only, that we will be seeing. First let us see if at all the object is kept at infinity. So I'll just erase this one. If I consider the object is kept at infinity, let me take this as infinity. This dotted line indicates or represents the object is kept at infinity. So here what we consider is, we'll take one ray which is parallel to the principal axis. I'll consider one incident ray which is parallel to the principal axis. As you all know, this is a convex mirror which is also called as diverging mirror. So what is going to happen here? Here the incident light is going to reflect, right? So how it is going to reflect? It is going to diverge. So what I will do here, I'll draw the reflected ray, which is going to diverge. So this is our reflected ray. Is that clear? So suppose if I name it as A and this as B, and this as C. So AB is the incident ray and BC is the reflected ray. So now if I extend this reflected ray, you find reflected ray is passing through the F, because the incident ray was parallel. The incident ray was parallel to the principal axis. Therefore, the reflected ray must pass through the principal focus. That is the one of the rule for the spherical mirror. Is that clear? Now second ray, what I will do is, I will take that ray, the incident ray, which is passing along the principal axis. the incident ray which is passing along the principal axis. So when it is passing along the principal axis, it is going to make 90-degree angle to the surface of the mirror, which means that the reflected ray is going to reflect back along the same path of the incident ray. Is that clear? So which means that this ray, this reflected ray, when you extend, this is going to meet at F. It is going to pass through the principal axis, which means the two reflected rays are going to meet at F, which means that when the object is placed at infinity, you find that the image is formed at F. That means the position of the image, which means that the position of the image is at F. When the object is placed at infinity, image form is at F. And if you find the nature, okay, the nature of the image, so where is the image form? Nature of the image form is, you could see here. So this is the reflecting surface, right, onto the left hand side, and right hand side is the non-reflecting surface, which means that you can see the two reflected rays are meeting at a point F, that is behind the mirror. So whenever the images are formed in front of the mirror, then we call them as real images, and if they are formed behind the mirror, then we call them as virtual images. So here, since the reflected rays are meeting behind the mirror, we call it as the nature is virtual. And as you all know, all the real images are inverted, okay, and here, since the nature of the image is virtual, so the image is erect. So we will write it as virtual and erect. You can write it as erect or upright, okay. Inverted means upside down. Suppose if this is the position of the object, okay, if you are getting the image also same as this, then it is called as virtual image, okay. If you get the image upside down, then it is called as inverted, okay. And one thing you have to understand here, plane mirror and convex mirror, you will be getting only virtual images. No real images are formed in case of plane mirror and convex mirror. And now the third one. So three things that we have to always remember, that is position, nature, and the third one is size of the image. So you could see here the size of the image. So what is the size of the image? You could see the two reflected rays are meeting at point F. That means it is point size or diminished, you can say. So here the size of the image is diminished. The size of the image is diminished. Is that clear now? Okay. So what we have done, we have taken the object which is kept at infinity, and after drawing the ray diagram, we found that the two reflected rays are meeting at point F. So when we found that since the meeting point of the reflected rays is behind the mirror, behind the convex mirror, so the nature of the image is virtual and erect, and position of the image is at F because they are meeting at point F, and size of the image, when we found, it is diminished. So this is about the object when it is placed in front of the convex mirror at a distance. Okay, then these are the three characteristics of the image that we find. That is, the position of the image is at F, nature of the image is virtual and erect, and size of the image is diminished. So always you should remember one more thing, that is convex mirror and plane mirror are the two mirrors which will always give you virtual and erect images. Is that clear? Yes. Now moving on to the next second one. So second one, we said that no matter wherever you place the object, okay, no matter wherever you place the object in front of the convex mirror, you will be getting the object at the image will be formed at one position. Okay, let us see now. So wherever the object position is in front of convex mirror. Okay. Now, let me draw a convex mirror. So every time when you are drawing the convex mirror, you should remember the definition of the convex mirror so that it would be easy to. Okay, so now I have drawn the convex mirror. Now I will take a point P, which is pole. You already know what is this pole. Okay, I'll take it here. Now let me draw one path principal axis which is passing through the pole and center of curvature. Let me take one as here it as center of curvature, and let me take the midpoint as F. So while drawing, if you are using the pencil and the compass, okay, at that time when you draw a circle of radius 3 centimeter, then 1.5 at a distance of, that is half of the radius, will be your principal focus. Okay, so that you have to make sure, or you can take a proper scale and you can draw. So here now suppose this is the pole, and anywhere in between, wherever you place the object, so wherever the object position is in front of convex mirror, that is between infinity and pole, no matter wherever you place the object. Suppose if I take this as infinity, so wherever, if you are going to place the object anywhere in between the pole and the infinity, so this is the, beyond this is infinity, so in between pole and infinity. So let us see where we are going to get the image. So suppose if I take the object, okay, let me, okay. So now first one, let me take that it is a parallel. The incident ray is parallel. The incident ray is parallel to the principal axis. Incident ray is parallel to the principal axis. So after reflection, it must pass through the principal focus, right? It must pass through the principal focus. Okay, this is one. Next, second one, if I take that the ray is passing through center of curvature. See, I am going to draw the incident ray passing through center of curvature. Okay, passing through center of curvature. So where it is reflected, so from here, see here, this is the incident ray. Okay, this is the incident ray which is passing through the center of, which appears to be passing through the center of curvature. Okay, where it is reflected, it will be passing along the same path. So if I draw, I'll show this in the dotted line, since this is behind the mirror. So you could see here, it will be reflected along the same path. So now if you find these two, this is also reflected ray, this is also reflected ray, you can find that the two reflected rays are meeting in between P and F, in between P and F. Suppose if I take this P here, okay, so between P and F, you could see that the two reflected rays are meeting in between P and F, which means that the image is formed in between P and F, which is formed between P and F, and where they are meeting, there you have to draw the arrow mark, and when we draw the arrow mark, you can find that the object, you can see the object size is larger, and when you compare it to the image, the size of the image, so size of the image is smaller, that is diminished. Okay, so suppose if you take one more position, okay, if you place the object somewhere here, if you place the object, so again if you draw one, you might be thinking like I did not explain about the nature, characteristics of the image form. Once after this one I will be explaining you, because in wherever you keep the object between within the infinity and the pole, you will be getting the same characteristics. Okay, so first let us see this one. So this is the incident ray. As this incident ray is parallel to the principal axis, so what is going to happen? We know that this reflected ray must pass through the principal focus. So let me draw a reflected ray which is passing through the principal focus. Okay, so now one more ray we have to take. So let me take that which is passing through the center of curvature. If I take which is passing, or let me take at the pole. Okay, I'll take it at pole. When the incident ray hits at a pole, so you know that what is the rule? So whenever the incident ray hits at a pole, it is going to reflect back in such a way that it is going to obey the second law of reflection, that is the angle of incidence and angle of reflection will be same. So it is going to reflect in such a way that it is going to make an equal angle with the principal axis. Okay, so let me so this will be our reflected ray. So if I extend, because no matter the incident rays or the reflected rays, if I am going to extend in front of the mirror, they are not going to meet, they are going to diverge, because all the rays when they hit onto the convex mirror, they are going to diverge. So you have to extend them behind the mirror, there only they are going to meet. So if I extend this reflected ray, I hope you all are understanding. Okay, so now you could see here the blue color line, okay, the rays, these two are meeting at this point, and again you can see that where they are going to meet, they are going to meet between P and F. The intersection point is between P and F. Is that clear? So here what is happening here, you could see the characteristics. If we discuss about the characteristics of the image formation in case of convex mirror, when the object is placed between infinity and pole, the first characteristic, what is the first characteristic? That is the position of the image formed. The position of the, where is the image position? P and F, between pole and principal focus. And the second one is nature of the image. So what is the nature of the image formed here? Nature of the image formed is virtual, because it is behind the mirror. So virtual and erect. So all virtual images are erect, virtual and erect. And third one is size of the image, and you find that, so wherever you keep the object, in every case you find that the image size is smaller than that of the object. Okay, so size is diminished, you can write, or you can write it as smaller than that of the object. Is that clear? So like you can draw this, and you can wave this video, and you can try to draw after that, so that you will be able to understand. Why? Because this seems to be very easy when you are learning, okay, and when someone is teaching you, okay, and even it is easy to understand also. But when you actually start drawing using your pencil, scale and all, so at that time you find a bit difficult. So you have to practice a lot, and once if you practice this one, and this is going to help you in the ray optics topics in your second year. We have a ray optics topic in the second year, there also it is going to help you. So have the basics properly, so that you can understand the higher version of it. Is that clear? So this is the image formation in case of the convex mirror. So only two positions we have, okay, that is, one is at infinity, and the second is anywhere, no matter where the object infinity and the pole, you will be getting the image at one position itself, that is between pole and principal focus, and the size of the image will always be diminished, okay, and then the nature of the image will always be virtual and erect. Is that clear? So now a question might be popping up in your hand. So what is the use of studying this one? Is it going to help us anywhere? Yes, definitely it is going to help you. Okay, so the convex mirror. So now if we study about the uses of the convex mirror, where we are going to use this convex mirror, then that will definitely help you. So where these convex mirrors are used? So I hope everybody has a vehicle. Okay, it might be a two-wheeler or a four-wheeler. So you could see the rear view mirrors or the side view mirrors that you have. Okay, so those are the convex mirrors. Those are the convex mirrors. So why they are going to use convex mirrors? Why not concave mirrors? That might be your question popping in your head. Why not the concave mirror? Why? Because you know that concave mirror will give you both real and virtual images, right? If the objects are far away from the mirror, then it will be real, and if the object is placed in between the pole and the principal focus, then you will be getting the virtual image. So when you are getting the real image, you know that real image is always inverted, upside down, so that may create confusion and you may not be able to take proper decisions. So the reason why they are using convex mirrors in the vehicles and all is just because it is going to give the wider view, it is going to give the wider view with the diminished image. So if at all, if you find that if any vehicle is behind you, when you see, you could find that the object is coming behind you, right? So there is an object with the how many objects also you can see. Why? Because the image formed will be diminished in this case, and also it is going to give you a wider view. That is the reason they will use the convex mirror. Not only in the vehicles, these can also be used in case of the shops also as a security mirrors. They will be used as a security mirrors. If there is any theft or any other illegal activities, okay, that is going to happen in the shops, okay, so in order to weave that, because it is going to cover wider area and all the images will be diminished, right? So that is the reason they will be using this convex mirror also. And not only in that case, even if you have seen in the big apartments or in the industries, okay, or in the schools also, wherever you have turnings, there also you find the convex mirror being used, okay. And even in the street lights also they use the convex mirrors. They use the convex mirrors in the street lights if at all you want the larger or divergence. If you want the larger divergence, then there also they will be using the convex mirrors, okay. So these are few examples or uses of the convex mirror. Is that clear? So hope you have understood this one. Now moving on to the next topic, sign conventions, which is one of the important topic also, and where students will face problem. They get confused, okay. What is this sign convention? Okay, so you know graph, okay. In the graph you have, I'll try to explain it with a very simple way so that it would be easy to understand you people, okay. So in graph you have, this is x on the right hand side you have x axis, on the left you will take it as x dash axis. Above the axis you will have x axis, you will have the y axis, and below you will have the y dash axis, okay. Suppose if you take, okay, in the convention method, right hand is always considered as positive and the left hand is always considered as negative, right? So here also when you are drawing, on the right hand side you will take the positive and on the left hand side you will take negative, and above, if you are raising in your life, if you are doing well, pretty well in your life, then what do they say? They take it as positive, right? So that is positive. Above this axis, x axis will be positive and below it will be negative, okay, negative signs. So now, how we are going to relate this to the spherical mirrors? In both the cases, it might be a concave mirror or a convex mirror, the sign conventions would remain same, okay. So first let me take the concave mirror. Let me take the concave. Okay, so now this is the concave mirror that I have, and concave mirror, you know, it is bent in surface. That means the reflecting surface is bent in surface, or you can say that the reflecting surface is curved inwards, okay. So now we know that the center of the aperture, that this is aperture m dash, center of the aperture is pole. This pole is considered as the origin, okay. The pole is considered as origin. Origin means 0, 0, where x axis will also be 0 and the distance along the y axis will also be 0, okay. So this pole is considered as the origin. And other thing, that assumptions that we have to make is always the object should be kept on the left hand side, okay. If this is the right hand side and this is the left side, okay. So object must be placed onto the left hand side. So because this is the reflecting surface. Okay, if you go and stand behind the mirror, you will not be able to see. You have to stand in front of the mirror in order to get a image. So here the object has to be placed on the left hand side because we have the reflecting surface facing towards the left hand side. So when the object should be placed on the left hand side. Okay, that is one criteria that you have to remember. When the object is kept on the left hand side, then the light that has to be made fallen onto the object should also be from the source of light should also be from the left hand side. Now, as I said, the pole acts as a origin, right? So now, from here, okay, so all the images that are formed, okay, the object position is onto the left hand side, so all will be considered as negative. Okay, in the concave mirror, suppose if this is the object which I am placing here, okay, so object is on the left hand side, so object distance from here till here will be your object distance, and object distance is denoted by small letter u, okay, lowercase u, okay. So that is the object distance. So object distance is negative. Object distance is negative in case of sign conventions of the spherical mirrors. Maybe it might be concave or convex. Okay. So now, when you draw, if this is the center of curvature C and if F is the principal focus. Now, where is the principal focus? We know that from P to F, the length or the measurement from P to F is focal length, which is denoted as small f. So this is onto the left hand side. So the focal length in case of convex, in case of concave mirror is negative. Okay. Focal f is negative. Okay. Why it is negative? Because the focal length falls onto the left hand side. So the focal length in case of concave mirror, the focal length is negative. Okay, and we have also already discussed about the object distance, that is u. Object distance u is also negative. Okay, is also negative. Yes, so object distance, and it might be object distance, it might be center of curvature, that is radius of curvature, or it might be the focal length. All these are going to be measured with a reference that is from the pole. From the pole itself, you are going to measure. Suppose if you want to measure the object distance, that is from P to the object distance, that is, let me take it as AB. So from P to B will be your object distance, that is U. From P to F will be your focal length. From P to C will be your radius of curvature. So the reference point to measure any distance will be the pole. Okay. Now object distance is over. Next we have third one is image distance. Okay. So if it is a real image, in case of the real image would be formed till where? When the object is placed at F or within F, that is principal focus and the infinity, you are going to get the real images, and there is only one case in which you will be getting the virtual image, that is when the object is placed between F and P. Okay, so here all the real images are formed in front of the concave mirror, that is onto the left hand side. So one thing you have to remember, the real images will have a negative sign. The sign convention for all the real images in the spherical mirrors is negative, and for all the virtual images it is positive, because the virtual images are going to fall onto the left hand on the right hand side. Is that clear? So all the real images are onto the left hand side. So all the real images, I'll write it as real images. Real images will have a negative sign, okay, and the virtual images will have the positive sign. Okay, sign convention. So what you have to say here? So here, even if you have to say the principal axis, here the principal axis is also real because it is in front of the concave mirror. So the principal axis will also be negative, okay, and the radius negative. So all these things will not be considering for formula, okay, for the formula. In the next topic we will be studying about the formula. For that we require the focal length, the image distance and the object distance. So we will be concentrating on those, and also about the height of the image and the object distance and all, okay. Height of the object and height of the image will be concentrated. So these things you have to remember, the main important things, that is focal length in case of concave mirror is negative, object distance either it is concave or convex, it will be negative, okay. Real images are always negative and virtual images are always positive sign, okay. You have to consider the positive sign for all the virtual images. The only reason why we have to take it as positive is the images are formed behind the mirror, so that is onto the right hand side, so we will be taking all the virtual images as positive. Now next, see, everything from the pole, if it is onto the left hand side, we will have a negative sign. From the pole, if you are measuring onto the right hand side, then they all will be positive. Is that clear? Okay. So in your books they have given that if the light ray is passing, okay, towards the mirror, okay, towards the mirror, then they have negative, positive, and if they are away from the mirror, they have taken it as negative, which means that, so if the rays are moving, that means they are moving towards the right, so they have considered it as positive, and if the reflected rays are moving they are moving away from the mirror, so they have taken it as negative. So that might be confusing, so the best you can remember is all the real images, okay, that is onto the left hand side or in front of the concave mirror, if you get anything that is onto the left hand side will be taken as negative, and one behind the mirror will be taken as positive. Is that clear? So just go with this graph method so that could be easy to understand. Hope this has understood to you all, okay. Now next is image. Now if this is the object, right, now object distance we have taken, now the height of the image or size of the image you can say. See, when we say size, most of the time what happens is it will be a confusion whether size is only in case of the length, okay. So no, it might be the diameter also, he may say the width also, so anything, okay. So sometimes he says size of the object, sometimes he says length of the object, sometimes he would give the diameter of the object also. So when you are focusing onto the any object, the spherical object, okay, so when camera, if you are focusing the camera onto the object and if it is in a spherical shape, then obviously you will be going with the diameter, right. So diameter is also the size of the object, it could be the length of the, if it is in a height, okay, so then you will take length, okay. So this is the size of the object. So this size of the object, if it is above the principal axis, it is considered as positive, and if the image is formed, okay, below the principal axis, then that would be considered as negative. So now I think it is very clear to you all. Maybe like you might have answered to yourself that all the real images, the height of all the real images is negative and height of all the virtual images are positive. Why? Because the virtual images will be above the principal axis and all the real images will be below the principal axis. So suppose if it is beyond C, then you are going to get the image somewhere here between C and F, right. So this is real image, so it is inverted, so that is in the below the principal axis, the image is going to form below the principal axis. Suppose if I keep the object between P and F, then you are going to get the image somewhere here behind the mirror. So you can see that this is the height of the image. So how it is denoted? Height of the image is denoted by H subscript I, and height of the object is denoted as H, that is lowercase h O. Is that clear? And here also it is. So only thing is that real images, okay, real images, the height of the, I'll write it here, Hi is the height of the image and HO is the height of the object, okay. So here all real images height or height of all the real images, okay, all real images height Okay, you can make it as the height of all real images. You can make it all real images height is taken as negative, and I'll write it here. Height of all virtual images is taken as positive because they will be above the principal axis. This is all about sign convention. Okay, so one thing, from P only you have to measure all the distances. Okay, so from P, if you are going on to the right hand side, that is behind the mirror will be considered as positive, and if you are moving away from the mirror, okay, then that is from the P onto the left hand side, then it would be considered as negative. And if it is above the principal axis, if you are measuring the height of the image or object, that could be the positive, and if you are measuring the height of the object or image below the principal axis, then that would be considered as negative. So this is all about sign convention. Hope it is understood to you all. Okay, so now the last topic of this reflection would be mirror formula. So you have to remember this one. Based on these only we will be discussing about the mirror formula. Okay, so let me keep this diagram as it is so that it will be easy for you to understand. So now before going to the mirror formula, you know what is mirror, okay, and you know formula. Formula is something wherein we have to substitute the parameters wherein you get the answer, right? That is a kind of equation it is. So here also, here the mirror formula will tell you about the image distance, okay, which will be telling you about the relationship between the image distance, object distance and the focal length. So suppose if I take you through the mirror formula, we have mirror 1 by V plus 1 by U is equal to 1 by F. So image distance is V, object distance is U, and focal length is F. So here this is the mirror formula. This mirror formula is telling you the relationship between the image distance, the object distance and the focal length. So if I have to, the reciprocal of the focal length is equal to the sum of reciprocal of image distance and the object distance. This is how you can define. Okay, so it has not given in any of the book. They have given just like mirror formula is the formula which will tell you about the relationship between the image distance, object distance and the focal length. So if you want to remember, you can redefine it as the reciprocal of the focal length is equal to the sum of the reciprocal of image distance and the object distance. You can define. Okay, so this is about the mirror formula. So now, so this derivation, of course you have a derivation for this, but for your 10th standard the derivation is not important. That you will be studying in your second year class, the derivation. Okay, so there you can learn the derivation. Okay, now next we have the magnification. We have magnification. What is magnification? Magnification is nothing but anything that has been enlarged, the object that gets enlarged. So here the ratio, it is the ratio of height of the image to the height of the object. Okay, so magnification, what is that? The magnification is the ratio of height of the image to the height of the object. Okay, so that ratio whatever we get, that we call it as magnification. Okay, and in case of mirrors, okay, in case of spherical mirrors, what do we say? That is the linear magnification we say, that is again here height of the object to the, ratio of height of the image to the height of the object is called as magnification. And here as we are discussing about the concave mirror, okay, here in the mirrors it will be minus. It might be, let me write it like this, M is equal to, so in the spherical mirrors it is H minus HI by HO. It is minus HI by HO. So the reciprocal, the ratio of height of the image to the height of the object, okay, with a minus sign is the magnification of the spherical mirrors. Okay, so we will be looking tomorrow about all these mirror formula, and how to put that into the problems and all. So that we will be studying in tomorrow's class. Hope that you all have understood. So hope you have a great day. Thank you so much.